All right, so we're looking at finding inverses and graphing them. So this whole chapter has been about radical functions, right? So we're going to be finding the inverses of these cube root functions and these square root functions. Okay, so here's our steps for finding the inverse of a function. You switch the x and y and you solve for y. Okay. Something else, you might have to correct this on the notes. I'm not sure. I had to fix it on my PowerPoint this morning. This should say CD. This should say AB. I think I've got it wrong on your notes. You might want to double check that once again. This should say CD. This should say AB. Okay. So something that we talked about earlier this year was that this is the symbol for the inverse of a function, right? A little negative one up there. And something about their domains and ranges, that the domain of f will be the range of the other. And by the way, this should say y, and so should this. I have a lot of boo-boos there, because range is all about the y values, right? So once again, there's another correction there, that the ranges should both have a y in the middle, not an x. So the domain of the original function is the range of the inverse, and vice versa. The range is the domain. Okay? And that's because in an inverse function, the x's and y's are swapped. And since domain and range are just the x values and y values, that makes sense. All right, let's go ahead and actually get down to work here, down to business. All right, so example 1, I want to find the inverse of this function. Okay, so first step is to switch the x and y, right? Now we want to start getting that y by itself. So what might we do to get y by itself? You want to get rid of the numbers that are outside of the radical first. So in this case, I have a 2 in the front of the radical and a +2 after it. Probably a good idea to get rid of the one that's being added or subtracted there at the end first, so we'll do that. So that gives me x minus 2. And then we can get rid of the 2 in the front by dividing, right? Okay, so now I've got the following. I have x minus 2 over 2 is equal to the cube root of 4y minus 3.
So when you're dividing by 2, you don't just cross it out and I think minus.
Well, that's a good question. Now, you can't do that. So the reason, that's a common question, actually. Glad you brought it up. So when you have something on the bottom, that means you're dividing it. Okay. Now, up here for this example, we have a times b, and yes, division cancels multiplication because they're opposites. But in this case, on the top we have a plus b, and division does not cancel addition, so you can't do that. Okay. So in this case, since we have minus 2, we can't do it. Over here, it's 2 times that square root thing, right? So the division will cancel the multiplication there, but it won't cancel that one. Good question. All right. So back to this thing over here. So we want to get y by itself. Here's the part that I want to make sure you guys get. I want to get rid of this cube root. What's the opposite of a cube root? That's right, third power. You raise this to the third power. That's how you cancel the root. So the third power cancels out the third root. And that leaves me with this. And from here, I think we kind of know what to do. We would, if we want to get y by itself, we would add 3 to both sides. Notice that you're not going to be able to add that 3 to the purple part because that purple part is being cubed. Oh, that's supposed to be a 3. All right. And then what we would do is we would divide everything by this 4. Now you could leave your answer like this. It's really kind of ugly, but I'm kind of okay with that at this point. I think one thing that they might, I mean, we could leave our answer like this, but for those of you math buffs that kind of want to go further, this is fine. Just leave your answer like that. But for you guys who might want to see how it would probably look like usually, because that's not very, this is a cubic function, and cubic functions don't usually look like this, okay? Cubic functions would usually look something like this. Okay, so first of all, what they would probably do is they'd probably divide the 4 separately into the top and bottom. So in this case, if you have this over 4, that's the same thing as multiplying it by 1/4. But you also have to put that 3 over 4 there. So you see how that looks a little bit more like what's up over there? So instead of putting this thing over 4, we can just put a 1/4 in the front. That kind of makes it, that way you see your A would be like that, right? Another thing is, this doesn't have any like big over anything here, does it? So once again, this is another ugly part that they would probably split it up like this, where they would put x over 2, but they'd probably write it like 1/2 x, and then 2 over 2, which would be 1. Now you don't have to do those steps, okay? But this looks more appropriate. So if you want to write it just to kind of develop your math skills a little bit, but I'll take this for today. You guys can stop there if you want. Yeah.
You know this where we divided the 2 and it crossed out when it was 2 times the radical.
Yes.
So if 2 was bigger than the x minus 2, then would that number just still stay under the x minus 2?
Yeah.
Or,
all right, so this is the cool guy answer. Wearing sunglasses, as you can see. Trying to be a cool math man. This is the happy student answer, because you get full credit anyway. All right. So I gave you guys a name here. Go for it. So there's our answer. Now these two functions are inverses. Now we're not going to graph the inverse of a cubic function right now, but just for the heck of it, I'll talk about it. you guys know cubic function. This cubic function would be right 5, down 1. So like, got a positive A, positive B, so it would look something like that, right? All right.
So we're solving and graphing it just like that.
You don't have to graph it. We are gonna graph the square root ones in a minute, but the cube roots we're not. So as for this one, now cube root functions, instead of looking like this or this, they look like this or this. Remember how we talked about with inverse functions, they are reflections of each other? So in this case, I'm going to go left 1 up 5, which would be here, and this one would probably look something like that. Okay. Now, if you want to put them on the same graph, you kind of get a little bit more of a dramatic effect, because you can kind of see that reflection thing we talked about a while ago. You remember that? So cube root functions kind of look like that.
So you know how you explained yesterday what graph you did the very first one?
Uh-huh.
How it's labeled? Is it the same thing? Like the reflection?
Yeah, it's pretty much the same. All functions work this way, where you have an h and a k, which is always a starting point of some kind where you go over and up, and then from there, based on the shape of that graph, you kind of use reflections and whatnot to kind of get a general gist of what it's going. So what I did here was I just told you this is what cube roots usually look like. So if you know that, then all you have to do is shift it over and sketch the graph on there. So that's that. We're not going to worry too much about that for now. Just wanted to give you guys a little heads up. But for square roots, we are going to care about that a little bit, because something kind of interesting happens there that's worth talking about. So let's go ahead and take a look at this function. Now you'll notice this is a square root function. It's not a cube root. So first of all, let's graph it. Okay. What's my starting point? -1, -3. So let's plot that point. And then I've got a positive B and a positive A, so it's just going to go up and to the right. So it's going to look something like this. All right? So that takes care of part A. We graph it. Now let's do the domain and range. What x value is farthest to the left? And it goes to the right forever, correct? And then as for the range, what y value is lowest? Good. And after that, it goes up forever. So there's that. Okay, so what we're going to do now is I'm going to show my work somewhere else, but we're going to find the inverse of that function over there. Okay? Am I good to switch slides? Oh, thank you. Yeah. So Melanie reminded me that this should have a line under an equal sign, because it actually does equal this point. That is a solid dot. So I appreciate that. Thank you for bringing that up. Okay. So let's go ahead and I'm going to find the inverse of this function here. I'm going to switch sides though, because I don't have a lot of space. So it's y equals the square root of x plus 1 minus 3, right? So step 1, swap your x and y. Step 2, get the y by itself. Pretty much identical to the last problem we did. One step will be a little bit different, and that's this next upcoming step. Instead of raising both sides to the third power, what am I going to raise both sides to now? The second power. Squares, second powers, cancel out square roots, which are second roots. So this cancels the root. Bless you. Okay. And then finally we minus the 1. Yep. Okay. Go ahead and do that. So, bonus point time. Ready? You gotta raise your hand for it though. What kind of a function is this? Yeah? That's true. I'll give you a point for that. But more specifically, this function is a type of function by its own right. Go ahead. What is it? That's a real. I'm going to give you the full points for that, but that's not the type of function is, but that's the form this is in. Quinn? Good. You guys are all dancing around it. Yeah. There we go. I like parabola. Parabola is a good answer too. So let's flesh these things out a little bit because I like these 3 answers that I got here. So first of all, John, you're right. This is an inverse. So those are all great answers. I'm glad you guys said all 4 of those because they're all relevant. So let's start backwards. Let's start with Melanie's answer. This is an x to the 2nd power function. That's a quadratic. Now the graph of a quadratic is a U shape, which is known as a parabola. Now quadratics can be written in 2 forms. Standard form, ax squared plus bx plus c, and then this one, which is vertex form. So those are great answers. So here's what we know now, based on what John just told me then, is that apparently the inverse of a square root function is a quadratic function. Okay? Now, let's go ahead and, so that just set that up for me beautifully. I love that. That's great. Okay, so let's find the inverse. We did that. That was y equals, help me out. Okay, thank you. Okay. Okay. State the domain and range of the inverse. Okay. Let's do that. So now for this, we haven't graphed it yet, but we don't need to. Okay? Because since this function is an inverse of this function, then we know something, right? What would the domain of this function be? -3 to infinity, right? Because it has to be the range of the other one. And the range of this function would have to be the domain of the other one, so -1 to infinity. Okay, so now let's graph. We want to graph this inverse. So now we got to remember some stuff. We got to remember how to graph a quadratic. Okay, so what would my vertex be? Yep. So my vertex, let's write that. My vertex would be -3, +1. So we're going to put a dot there at -3, +1. Oh, yeah, you're right. Thank you. Thank you, Elijah. Right there. -3, -1. What are you laughing at?
She said it first off.
Oh, did she? Okay. Now, happy face or sad face parabola? Happy face. You go by this number here. So since my A is positive, that's a happy face parabola. Now I don't want you guys to draw this though. I just want you to watch me because because some of you guys might be writing in pen and you would need to erase something. Okay. But so if I were to make a happy face parabola with this vertex, it would look like this, right? Now, does that look like an inverse to you? It doesn't. There's something wrong here, right? This guy over here looks like only half of this. What half of my graph should I erase? The left half or the right half? You would erase this half. Why? Well, here's why. Because yes, this is a quadratic equation, but the thing is, if you're going to find the inverse of this function, its domain and range will be just as restricted as this guy's domain and range was. Okay? You're not allowed to have, if this guy's only allowed to have x values from -1 to infinity, then this guy's only allowed to have y values from -1 to infinity. If this guy's only got y values from -3 to infinity, this guy's only allowed to have x values from -3 to infinity. Okay? So since this guy's domain and range is restricted, when you find his inverse, it's his inverse, so he gets to call the shots. This guy's domain and range gets restricted, and you actually end up with only half of a parabola. Okay? What did you say? Amen. Amen. All right. So we good? So you have to erase half your parabola. Now you have to be able to identify which half. There's two ways you can tell which half to erase. One way is, in my opinion, just look at it. You can tell, oh, that half shouldn't be there. But if that's hard for you, what you could do is you could look at your domain and range. I know that my parabola's x values should only go from -3 and then to the right, because my domain says -3 to infinity. So I know that I don't need the part that's to the left. Okay? So there's a few ways you can tell. All right. So we did quite a bit there. We did quite a bit. Let's review. First of all, we graphed it. That shouldn't be a stumbling block because that's just a review question. Domain and range, same thing. Review shouldn't be a stumbling block. Finding the inverse, you guys did really good with it on the last slide, so I don't think you're going to stumble there. Domain and range, I think you guys will get that because it's just a matter of switching. And I think this will be your main issue here, is trying to graph it. So let's review that one more time before we go on any further. Opposite of this, keep that. That's your vertex. Happy face, sad face. You'll have to erase half of it though, and I'll let you see if you guys can figure out which half to erase. Okay, so that's the inverse of square root functions. There you go, circumstances. So, George, what's our starting point on the first one here?
2, 1.
So that would be here, and it's the same as the last one. Since my A and B are both positive, it goes up and right. Now I'm about ready to give you guys a different one when we finish this, where the direction is different. And because that direction is different, that's also going to affect which half you erase when we get here. But we'll talk about that more when we get there. So let's continue this one. Lally, what's the domain for the original function? Cool. And so, Lolly, can I bother you for the range as well? No. You always change the sign of that number when you write your starting point. Edward, what did you get for your inverse? Okay, good. And Joaquin, what's our vertex for the inverse? Well, actually, what's the domain of the inverse?
1.
Good. And the range would be? Okay, good. All right. Let's ask. Kalani's not with us. Let's ask. So, Andrew, what's our vertex on this quadratic equation here? Huh? 2, 1? Close. It's this one will be 1, 2. So it's over 1 of 2. And then I'm going to ask Elijah, Happy face or sad face parabola? Happy face. Positive A. So when this number is positive, it's a happy face parabola. And then, Gabriel, what half of my parabola do I erase? The left half. Now, it's not always going to be the left half, but there it is. Okay. So I want to throw a different one at you, and then after that, we'll call it a day. Okay?
You're gonna put negative over X on.
Yeah, we're gonna do some reflections here, and we're gonna see how that affects the outcome a little bit. All right. Okay, let's try this. So let's say y is equal to
I have a question. You know, homework is it gonna be negative in front of the radical?
could be. Okay. So just before we begin the problem, what two things do I need to do with this before I even begin?
Flip the X.
Flip the x and the 3. Good job. And
switch the X and the Y.
no, not yet.
Oh shoot.
Good. Factor out. So after we flip this, you're going to have to factor out a -1, okay? All right, so do those two things first, and then the rest of it will be the same. Okay, so first, so I can graph this, I'm going to reverse these around, and then I'm going to take out the -1. And so that would have been your first two steps. So based on that, John Castillo, where would our starting point be for this square root function here? Huh? I want to know, like, so I want to graph it. So what would my starting point be? What else? So the starting point would be this number, but the opposite sign, and then this number. So 3, 4. So over 3 up 4. Okay, now my next question would go to Steve. Steve, what direction is this square root function going in?
Down.
Down and right or left? Left. So if you have your chart from yesterday, it might help a little bit. So because this is positive, actually, Steve, it's going to be up, and it's going to be up and left. So your quadratic would look something like this, actually. Or not your quadratic, your square root function would look like that. So we have our starting point, and then it's up and left. All right, so that's your graph. Now, Amanda, if I wanted to start getting this thing solved for by itself, what would be the first thing I need to do? I forgot the number here, you guys. What was it?
3.
Plus 4?
Yeah.
So, man, if I want to start finding the inverse, what would I do? Move the 4 over. Oh, actually, I forgot to switch my x and y. Let me do that first. So move the 4 over. Okay. Braden, what's next? There you go. So raise both sides to the second power. When you do that, on the right side, these cancel, right? I think the -1 here might have thrown some of you guys a little bit. So, Nylea, what would you have us do next? Not sure? Okay. Nicole, what would you have us do next? Sure, we can do that. Some people might have distributed. That's fine too, but you're still going to have to divide by a -1 at some point to get rid of the negative. So in this case, if we do it here, these cancel, right? Now over here, you could leave it like this, but if you divide anything by -1, it just changes the sign, doesn't it? So this thing on top just becomes this then. That's kind of like the part that you're probably like, oh man, really? It's like, probably didn't know you had that would be helpful, but that's what you'd want to do there. Madison, what would you have us do next? Uh-huh. Oh, I didn't add the 3. Okay, so there's that. So if I wanted to graph that, what was it? It was negative x, what was it? Okay, let's graph that now. So, Quinn, what's my vertex of this parabola? What's the vertex of this parabola? Uh-huh. Over 4 up 3. So there's that. Giovanni, happy face or sad face parabola? That's right, because this number in the front is a negative, right? So it's going to look like that. But that's not really the inverse of the square root function, right? There's too much there. We need to erase some of it. Xana, which half would I erase? Left or right? No? So the other half? Does that look right? Yeah. That's the reflection we're looking for. Okay? So, so you guys had the basic idea, but I think that little negative kind of threw you guys for a loop a little bit. So hopefully you guys took good notes on that. But anyway, we'll call it quits right there. I'm assuming by all the zipping, the bell is about turning. Let's see.